Good morning, good afternoon, and good evening. My name is Whitney, and welcome to our webinar, Security for the Multi-Cloud, featuring both Arista and Zscaler. I am pleased to introduce the first speaker, our very own Cecil Christie.
Thank you, Whitney. Hello, I'm Cecil Christie. Arista Any Cloud Platform is the combination of Arista's vEOS router and CloudVision software, which can be used to provide automation and visibility for the universal cloud network architecture across any cloud. Arista's Any Cloud building blocks seamlessly marry the on-premises enterprise by leveraging routed tunnel overlays such as IPsec VPN and VXLAN for more cost-effective hybrid cloud management and services across and between clouds. A multi-hypervisor and multi-cloud routed architecture based on Arista Extensible Operating System cloud-grade routing connecting any workload, where some reside in the on-premises data center and others reside in the public cloud. Extended telemetry and automation with CloudVision for deep visibility between the data center and the cloud. And finally, a depth of partnering with leading public cloud providers, initially Amazon Web Services or AWS and Microsoft Azure, and soon with others, to make meaningful offerings and solutions incorporating cloud attributes at every place in your cloud. It is clear that multi-cloud will need an architectural approach and, most importantly, a common and uniform approach to the operations of disparate networks and resources in the cloud. When we talk about the Arista advantage and what it brings to our customers, we are talking about a set of common attributes, and those are distilled in universal cloud networking, an open programmable software fabric, and the Arista 5 A's: available architecture, any workload, automation, analytics, and any cloud. Everything that we do at Arista falls into one of these categories, from a very highly reliable and quality architecture to a broad line of 10, 25 to 100 gigabit hardware platforms. Before we get into selling the Any Cloud platform, let's review the reasons customers are deploying the Any Cloud platform today. If you attended our last webinar, Deploying the Arista Any Cloud solution, we explained why it is so clear that enterprises that are migrating workloads to the cloud will need an architectural approach and, most importantly, a common and uniform approach to the operations of disparate networks and resources in the cloud. When we talk about the Arista advantage and what it brings to our customers, we are talking about a set of common attributes, and those are distilled in universal cloud networking, an open programmable software fabric, and the Arista 5 A's: available architecture, any workload, analytics, automation, and any cloud. Everything that we do at Arista falls into one of these categories, from a very highly reliable and quality architecture to a broad line of 10, 25 to 100 gigabit hardware platforms. The ability to handle any workload across Ethernet and IP, and common techniques for automation and provisioning with CloudVision, advanced telemetry and analytics with our network tracers, and of course our fully programmable EOS software stack, and solutions partners that are incorporating complementary capabilities like Zscaler Internet Access. Arista's Any Cloud networking principles apply consistently to the public cloud, private cloud, and hybrid cloud environments, which is very powerful to a customer since they would not want to recreate a different approach for every environment. Within the Zscaler and Arista joint value proposition, Arista shoulders the network and management responsibilities. Arista starts with operational consistency across private and public cloud, with EOS as the foundation and rolling out across AWS and Azure. EOS also delivers deeper visibility with state streaming and event correlation, absolute essential elements for establishing any anomalies that we observe in a network. Arista EOS's network-wide provisioning, upgrades, rollback, and snapshots ensure consistent network-wide management. And finally, APIs that can be accessed across private and public cloud deliver additional customization for every customer's unique requirements. And now allow me to introduce Zawal Sharma from Zscaler.
Thank you, Cecil. So Zscaler and Arista partnership that we're going to walk you through in this webinar is how Zscaler and Arista have come together to simplify deployment of Zscaler Private Access solution using the Arista VEOS platform. Today, customers who prefer a multi-cloud strategy where you may be running workloads inside Azure, AWS, Google Cloud Platform, as well as your internal data centers, can host your internal applications either in these applications, in these clouds, but these cloud platforms, though, enable you to adopt cloud. It is very difficult to have the consistent user experience for two clouds, and two cloud environments are most likely not same when you think about setting applications or splitting applications across them. So the joint solution offers a multi-cloud platform where Zscaler service could be running and connecting users to a application which is split across 4 clouds, as well as a application which is running inside your data center to allow customers to create, migrate, and manage these application workloads for users who are distributed across the globe, and global network topology, which actually is going to be managed across these clouds using different platforms. Now, what Zscaler brings to the table for this partnership is Zscaler Connector, which is required. Think of Zscaler Connector as a replacement for your traditional VPN concentrator, which is deployed closer to the application. So instead of defining and managing yet another VM image or an RPM, you can actually run it inside the VOS router itself. Then you can define policies to make private apps visible to specific users, and all the connections would be routed through this single form factor which you're deploying on your cloud platform. And another big advantage is that you do not need to manage IP space or IP addresses just for connector and then VEOS. You can actually, connectors can leverage the VEOS IP addresses, so there's no need to get that IP address sprawl. And you can secure connectivity from anywhere independent of the network topology, because as we get embedded into the Arista platform, it becomes very easy for you to just manage your Arista through the Arista orchestration service, and Zscaler at that point is running as an extension of that cloud service, and you do not need to manage it as a standalone component anymore. I'm going to start with an overview of Zscaler platform and what Zscaler service provide to the customers. Let's start by looking at how people typically built an internet gateway starting early 1990s and how it has evolved over a period of time. As we see, people started by building a basic URL filtering solution and then adding a antivirus and a DLP and a SSL capability to their outbound internet stack as the attacks on the internet started getting more and more complex. Basic URL filtering was not sufficient to just block attacks which were being driven from the content and payload. So the complexity inside the DMZ or on the internet gateway kept on evolving and getting more and more complex. These internet gateways were meant to secure traffic going onto the internet. Now, as people started connecting inside the corporate network to the applications like SAP or Siebel or PeopleSoft, which used to run inside your data center, companies needed to build a VPN gateway to allow remote users to access these applications running inside the corporate network. So it started by building a VPN concentrator, then a full load balancing to balance the load coming into these VPN concentrators and to prevent denial of service attacks. So the VPN gateway and internet gateway define what sits inside the DMZ, inside the corporate network. Now, As cloud and mobility started disrupting the application delivery model, where applications started moving to the cloud, your users starting moving outside the corporate network, the old world of hub and spoke network, where you built internet gateways either at your headquarters or at regional facilities, became insufficient because users started connecting to the applications, which moved away from your data center into the SaaS applications like Office 365 or Box, or to IaaS platforms like Azure or AWS or Google. The perimeter-based control was not sufficient at that point of time. Applications such as Office 365 were built to be accessed from internet directly. Following the old world of hub and spoke network is going to add latency in the data path and going to compromise the user experience. In fact, companies like General Electric are planning to run 70% of their workloads from cloud and not from the corporate network anymore. And your users who used to connect from a branch or a corporate network are now going to connect to these applications directly from a hotel or a coffee shop or from remote offices. So it's not possible for you to secure these payloads just by extending perimeter to these locations. And then we work with customers such as Siemens, who are telling us that internet would be their new corporate network. When internet becomes your corporate network, how do you secure such a network? Traditionally, what has happened over a period of time as organizations have adopted cloud and users have become mobile, the concept of internet gateway and DMZ is also started going away. A lot of companies have started building these in virtualized data centers or service provider data centers, but at end of the day, you are still backhauling that traffic inside the corporate network for the remote users, or you are making the traffic trombone through your VPN gateway when they are outside the corporate network. So the disadvantage of this architecture is that users who may be sitting closer to the application that they're accessing still need to go through these massive stacks, and that compromises the user experience, and still they do not get the consistent security. What Zscaler has done is, instead of building a perimeter around your network, we have kind of built a perimeter around internet. So instead of old network model, which was hub and spoke based and MPLS based, customers are now looking at a network model which is more direct to internet based. With the advent of SD-WAN and faster broadband connections, people are able to do local breakouts from the branch without need to backhaul this traffic. The old security model, which was to secure the corporate network, has evolved to securing the user. So it is important to make sure no matter where your user is coming from, they get secure access to the application and they get a right level of access through the application that are required for their productivity. So Zscaler, in order to enable the secure transformation of organizations from a hub and spoke network to a local breakout network, and from a centralized security model to a decentralized security model, we have built two sets of services. We have disintegrated your external or outbound security stack into what we call as Zscaler Internet Access, which provides a good set of capabilities for you to send your traffic to the internet. So it makes sure that nothing bad is coming into your network and nothing good, which is your corporate IP or your organization's intellectual property, going out to the internet. Here, this is where we offer services such as advanced threat protection, data leak protection, access control with URL filtering and cloud application, and next generation firewall. Then we also take care of your inbound stack, where users are connecting into the corporate network and you're tromboning traffic through internal network into SaaS applications. You don't need to do that anymore. With Zscaler Private Access, users connect to an application without backhauling traffic. They do not get the network access, but access to the application that they get access to. And we will dig deeper into the Zscaler Private Access architecture. The goal of this webinar, along with Arista, is to make sure that we show you the joint value proposition of Zscaler and Arista, how you can leverage the Arista VEOS routers to connect to private access and simplify the inbound stack architecture significantly. So Zscaler Private Access is a revolutionary technology. It is a way to do remote access in a way which is very challenging with traditional VPN. So the 4 key tenets of value around Zscaler Private Access are that remote users should never be placed on the network. With traditional VPN architecture, you need to bring users' traffic back into the corporate network through a VPN client. That is not required at all. It is very important to provide users access to the application. Typically with a VPN concentrator, you are connecting user to your network and not to the application. Once user is on the network, they can go and they can actually access any application. You can access restrict applications, but users can discover those applications. Applications should be invisible to unauthorized users. Users who are not supposed to get access to, say, finance applications should not be able to even discover those applications. So make those applications invisible that users do not have access to reduce the attack vector. Policy-based access is also very, very important. Define which users have access to what applications. This is very important because a lot of time with traditional VPN model, the access controls have to be left to the application server itself instead of the VPN stack. And since internet becomes your new corporate model where you do not have any security stacks running at branch or your headquarters, Zscaler Private Access, the key tenet that it addresses is that it connects user to the application from any device using a secure tunnel, which is TLS encrypted, and there is no chance of man-in-the-middle attack on that tunnel. So the platform services that map to these key tenets include secure app access, that user is never on the network, and if you want, you can do double encryption of these tunnels using your own organization's PKI framework. It allows you to do app segmentation, so you allow user to app connections. It prevents the lateral movement, so if user doesn't have access to a acquired organization's application namespace, they simply can't even discover that. And it gives you internal visibility. It is very important for you to know what applications are running inside your corporate network. With Zscaler Private Access, we not only provide secure remote access, but we also can discover all the applications that are running inside your namespace. And application protection, finally, which is where, since we are running as a cloud service, we kind of hide your corporate network from a malicious player. So if someone is trying to do a denial of service on your namespace, it is not even visible to them. And we can inherently load balance traffic from our cloud to various application clusters or application groups that you have defined, whether on Azure or AWS or your own data center. So next section, we're going to focus on how Zscaler Private Access works. It all sounds great, but how is actual workflow from a end user perspective? So you can get started with Zscaler Private Access literally in 10 minutes. All you need to do is deploy Zscaler app on the endpoints, which could be pushed using a GPO policy on Windows PC or through an MDM on iOS or Android device. Then you deploy connectors in your data center or on Azure or AWS. So connector is equivalent of a VPN concentrator in the old world, but there is a major architecture difference that connectors, unlike a VPN concentrator, do not make inbound calls. They only connect outbound, so there is no need for you to change your network architecture or make any inbound firewall rule changes in your network to run connectors. And if you're running as we'll show you a demo, if you're running Arista infrastructure in your data center, then it could be embedded inside Arista VOS device as well. Then you go to Zscaler web console to define policies and app access policies. Make sure you are able to authenticate users, set up identity with your corporate identity provider, and define policies based on that. In terms of workflow, if a user is trying to access a corporate application, they make a request to go to, say, hr.company.com from their iOS device or their PC. At that point, our Zscaler app, the endpoint agent, actually connects to what we call as ZENs, or our Zscaler enforcement nodes. We have 100+ data centers across the globe. So our service automatically discovers which is the nearest Zscaler ZEN to the user. At that point, user gets authenticated with your organization's identity provider. It could be an on-premise ADFS, or it could be Okta or Azure AD. We are identity agnostic. The Zscaler app or agent that we have essentially is doing a split tunnel on the traffic. So As I mentioned earlier, we have a Zscaler Internet Access Service, which makes sure that user connects to internet in a secure manner, and we are securing those payloads by doing content inspection. So if traffic is destined to an internet-bound application, we actually run it through our security stack. If traffic is destined to your internal namespace, say star.company.com or hr.company.com portal, for example, our Zens would know at that point that this traffic is going to an internal namespace, and at that point, we will create a secure TLS connection from the agent, and that connection will land on our Zen. At that point, policy is checked to determine if user has access to that permitted application. If you are trying to go to finance.company.com and you do not have access to it, that page would not even open or resolve for you. It is like going to a site on internet that does not exist. So we kind of make your application namespace completely dark to the user. Those applications that they do not have access to, they simply cannot access that. If user have access to that application, we find a optimal path to connect to that through Zscaler. So we, at this point, know where those connectors are installed. You can have a very large application running in 4 different data centers or in different Azure VNets, for example. With our connectors, we will know that I can load balance this user's traffic to a specific connector running in a Azure zone versus an internal data center, and I will route this user's traffic to the or redirect this user's traffic to that specific Zscaler Zen. And if connection is allowed, our connectors at that point initiate a outbound connection only, and Zscaler app initiates a connection from the agent. Our cloud brokers or Zscaler Zens at that point stitch that connection together, and we load balance that traffic to go to this specific application. In this example, it is Jira application running in a public cloud. And we get out of the data path, because for Zscaler private access traffic, you really don't want any cloud service to look at that traffic. So we connect the user to the application securely, and then we get out of the data path. And user is connected to the application at that point. And through the same centralized single pane of glass console, you can actually then see the user policies, which user is doing what, and you can find anomalies, for example, or get more detailed reports out of that. So this is in a nutshell how Zscaler Private Access works from an organization perspective. Now, what are the key enterprise initiatives when Zscaler Private Access could be adopted? First and foremost is cloud adoption. If you are moving your workloads to the cloud, for example, moving your applications to Azure or AWS, we enable you to connect to these applications directly from an end user perspective. You don't need to move your entire security stack to Azure AWS and run a stack inside the corporate network or buy direct connects from these vendors to just have to get a dedicated connection and better performance. If user is able to connect to these applications directly from a coffee shop or home, most of the service providers that they're going through are actually most likely are paired with Azure or AWS. So user most likely is getting the same level of experience going through a public hotspot, for example. So we enable this seamless experience without requiring to dial into a VPN client. Zscaler app is an always-on agent that inherently can split traffic based on where the user is going. Second key driver is mergers and acquisition. We had a customer who is a very large, globally distributed 300,000 user organization which acquired another large enterprise with thousands of users. The key challenge for CIO was to enable remote access or secure access for this acquired entity employees to the HR portal of this organization. In traditional VPN world, it would mean pushing agent, deploying concentrator, managing very, very complex policies. So with Zscaler Private Access, they were able to enable this access within a matter of a couple of days. Because all you need to make sure is that on these pieces, you can push an agent through your GPO policy, and then at your once user is authenticated with their own identity provider from the acquired organization, they can then actually be able to access this specific single application namespace just with one click of the button. That's it. So it makes it very easy. No need to resolve IP conflicts which you typically would run into with VPN concentrators, and there is no need to converge the two entities. You can still manage them as individual entities. Third use case is partner access. So If you give access to your applications to your partners and contractors, you want to make sure they don't get on network. There have been many security incidents where a partner or contractor got access to an application which was not well managed, and they were able to steal sensitive information. With private access architecture, you are giving these contractors access to only a single application. So this is a key advantage over a traditional VPN. And the most important use case for private access is VPN retirement. When we speak to our customers today across different market segments, we haven't found many customers who are happy with a VPN solution. So goal of Zscaler private access deployment is to simplify user experience and make it easy for people to access cloud applications. And this is done by never exposing your applications to internet or your namespace to the internet, and without caring about buying new hardware, more hardware every time you moving more workloads to the cloud. Traditionally with VPNs, the key scalability challenge comes in terms of the hardware or VMs that you need to deploy, where you need to scale the capacity based on number of concurrent connections. Since Zscaler service runs as a fully cloud managed service, our customers really don't need to worry about how many connections they need to establish and how much load it will add. We manage that for our customers. So we enable experience that user want based on the security that you want to set up for your users within your organization. So the key context of Zscaler private access from an organization perspective is that it enables private access with strong authentication, which means we give access to the users to applications based on what privilege they have. We can integrate with your directory. We can have SAML-based multi-factor auth enabled. If you have that enabled, we are agnostic to it. We fingerprint each device with Zscaler app and your company certificates, and we can do device posture-based policies. So if you have a device which is not running a corporate certificate and you don't want to allow that device to connect to Salesforce application or say your SAP application, we can enable that. There are 4 contexts of policy. You can define policy based on application context, say access to a specific app or application groups which are sitting behind a connector could be could be restricted based on the application that users are going to. This location context, for example, you can say a largely distributed application which has servers in Germany and in US, you want to restrict access for applications sitting in Germany only to the German cluster, you can do that because we are location aware with Zscaler private access. Then device context, because we run an agent on the device, we can fingerprint each device, we can use that as a policy criteria. And finally, based on the Active Directory sync or identity federation we are doing, we know who the users are, which departments or group in Active Directory they belong to, and we can do policy based on it. So as an example, you can have a policy where your HVAC contractors can get access to the HVAC applications only, while your executives have access to finance and financial applications that are running in your namespace as well. So another key differentiation that Zscaler Private Access brings to the table is discovering of private application, their usage, and their health monitoring, which is similar to what CASBs do for public namespace application. We do that for private namespace application. So when you deploy a connector on your on-premise or on your VNet or a VPC, which is essentially when you have a Arista vRouter running there and our connector is enabled on it, we actually monitor all the outbound calls from that location at that point. So we provide you visibility into all the applications that run on your namespace at that point of time. And we show that on our reporting UI in a very graphical manner, where we actually not only tell you that we discovered specific application, we also see how many application servers are running inside, how they are clustered inside your organization. And we can then identify any anomalous pattern. This is a very awakening moment for a lot of organizations where they expect that they are running X number of applications inside their namespace, but when they run Zscaler Private Access, we end up discovering sometimes 2x or 4x applications. A lot of these are legacy applications which are sitting there. For example, a developer added an application server which has been running for 10 years, and some users are using it, but no one was aware of it. discovery is very simplified. It is a name-based query by a user to any application space. We see that and we'll discover it and we'll give you visibility into it. And we have a full dashboard for it at that point of time. So you can see which user is accessing what application, what are high transaction volume-based applications, and which applications are used by which users. And then once you have discovered those, you can manage and put policies around that. So this is a brief overview of Zscaler Private Access solution. At this point, what I would do is I will dig deeper into a demo of Zscaler Private Access running on Arista VEOS router. So in this demo, what I'm going to do is I'm going to download a Arista VEOS router from AWS account, and on that Arista VEOS router, we are actually have embedded the Zscaler Private Access connector, and that connector would be then turned on, and it will enable itself and be able to act as a connector, discovering applications and become the connector for applications that are for the application groups that are running inside that VPC inside in AWS. We will be able to connect these applications. So to start the workflow, I'm essentially going to marketplace products and searching for Arista VEOS router. And once I have found the right product, I'm setting it up. What I have done is I'm going to associate it with a current VPC that I have set up for this demo purpose. I am going to launch this on my VPC and wait for it to come up. It takes typically a minute for a VM to come up on AWS. So while this is coming up, we are going to also see that there's a public IP that has been assigned to this vRouter, through which I can handle the routing in and out of this VPC. Once this VEOS router is on, I'm going to SSH into the container in which I have installed this VEOS router. And what you would see is that inside this router, I'm able to do my namespace resolution to make sure that I can resolve this router. And then I would be able to log into my connector instance. So I'm actually going to the Zscaler Private Access instance where I'm going to enable this connector which is running inside AWS. Now, first thing that we do as part of provisioning a connector is that each connector has its own identity on our cloud, and that is managed with a API key. So what I'm going to do right now is copy the key from the Zscaler Private Access console and configure that key in the connector which is running inside the VEOS device right now. So as you can see here, I am actually configuring that key here, and I'm going to save this configuration. Once this configuration is saved, I will exit out of this container and I will wait for my connector to reboot and establish a connection outside to Zscaler Cloud. Every cloud service that we are running essentially identifies itself with our cloud using a unique key and unique certificate. So we know at this point that this connector is up and running. So I'm going to look for the connector health at this point, and once the connector is up, connector would start showing up inside this container where I'm also running my VEOS router. Now, while this comes up, I would also go back to the Zscaler Private Access console, and this is where I would show you this connector which just came up, and show you that it has been authenticated with the cloud and it is able to handle traffic as well. As you see on the screen right now, the ZPA connector, which was configured inside this container with VEOS, has been set up and the state has changed to running. So my connector is up and I'm able to access that through an SSH session. Now I'm going to go to Zscaler Private Access Console, and I'm going to refresh my screen a couple of times. It takes between 15 to 20 seconds for this connector to reflect. As you see, the connector is up. It is showing that the status is up. It is session state is disconnected right now. It is trying to establish a connection. And now I see the config has been pushed to this connector. This connector is up, healthy, and is authenticated with Zscaler Cloud. And the software version is also noted. So as we update the software version, the new version gets pushed out automatically, and it gets updated as well. So this is a brief demo of embedding the connector software RPM inside VEOS to simplify the deployment of connectors which are used to connect inbound into the applications from any device anywhere in the world. And this simplifies the rollout of Zscaler for private access, especially if you have Arista VEOS platform deployed on your cloud, as well as your data center as platforms as well. Thank you, and back to you, Cecil.
Let's review from the last Arista webinar what the any cloud platform can offer you as you interconnect your enterprise with the new environments of the public clouds. And these are the key reasons that customers are deploying the VEOS router and Cloud Vision today. Number one is consistency. We are going to have the same look and feel of EOS no matter where we deploy this. It is going to look exactly the same and give us the same tools that we are used to for troubleshooting. Number two is dynamic routing with scale. We are going to be able to run BGP in the cloud, and we are going to be able to simplify the design of our cloud native route tables by building standards-based spine and leaf network fabrics within the public cloud and across both public and private clouds. Number three is transitive routing. Now that same spine leaf design that we have implemented in the data center that is scalable and reliable, we are going to have the same leaf spine, scalable and manageable design for the cloud. And finally, number four is visibility. Arista Cloud Vision and Arista EOS software provide real-time visibility with active probes and continuous streaming telemetry from all of your places in the cloud. And Cloud Vision provides real value for troubleshooting and reducing the mean time to resolution for problems in our network. The Arista Any Cloud approach will continue to transcend the other places in the network as well, as every location in the enterprise can also make use of this solution over time, from the data center to the branch to remote consumers and campus workplaces. As we consider the hybrid cloud use case, there are by definition many different places in the cloud at play. In the public cloud instances, which are likely the newer part of your IT operation, but also in the private cloud and the on-premises data center plays into the Any Cloud scope. And the Any Cloud solution provides a consistent architectural and operational approach across all these use cases.
I see the questions flooding in our Q&A box. We're going to take some time to get those answered right now. When will the Zscaler and Arista common solution be available?
Zscaler and Arista are looking at building out a solution that spans the data center and the branch office. So our current focus is on building out Zscaler's private access service offering, which relates to applying security policies across workloads that have been moved to the public cloud. So we expect that work to continue for the next 2 quarters or so. And then we are also looking to bolster Zscaler internet access with some developments. And we ask that we all stay tuned for that one.
What public cloud platforms does the integration support?
So both Zscaler private access connectors and VEOS routers are available on all publicly available IaaS platforms, including AWS, Microsoft Azure, and GCP Google Cloud Platform as well.
What is the scope of the integration today, and what are the future plans?
So the current scope of the integration is to run the ZPA connectors embedded in the VEOS router. We are working with Arista to see what are the other avenues on we can expand this relationship, including with Zscaler Internet Access product and making it simpler for people who are running Arista on the edge or in the cloud or in the data center to connect to their applications, or as they go out to the internet, how we simplify this architecture.
How does Arista MSS relate to Zscaler?
Arista's MSS focuses on east-west security in enterprise data centers. Zscaler, on the other hand, looks at providing secure access to corporate employees that may be seated within outside of the corporate perimeter, and provide a Zscaler-based firewall approach and a secure approach to them accessing internet resources. So both Arista MSS and Zscaler ZIA are complementary technologies which taken together provide a holistic solution to an enterprise's security needs.
What platforms does the Zscaler app support today?
Zscaler app is a lightweight agent from Zscaler that runs on all common platforms, including PC, MacBooks, Android, and iOS. And you can push it through a GPO, manage it via an MDM. The goal of Zscaler app is not to do any heavy processing on the endpoint, but to send traffic to Zscaler Cloud with the user context. So it is supported on all common platforms today.
That is all the time we have. Thank you so much for joining us today. If we did not get to your questions, please feel free to email us at webinars@arista.com. A recording of this webinar will be available on our website.